Part of understanding and working with quadratic equations involves word problems, particularly those that require you to convert between the three types of quadratic relations: standard form, factored form, and vertex form. By the end of the section, you should be able to solve problems involving quadratic relations using the skills learned in this course, which include factoring, using the quadratic formula, or completing the square. You will also be able to model a variety of quadratic equations describing a variety of situations and contexts. This video in particular will focus on what are called max-min or maximum and minimum problems. The wording maximum or minimum implies that you will need to find the vertex of the quadratic relation and or work with a quadratic equation in vertex form. The manager of the hardware-to-go store knows that if a package of batteries is priced at $4.95, he will sell about 600 packages a week. He knows that for every 10-cent increase in price, his weekly sales will decrease by 10 packages. To solve this question, we will need to find an algebraic expression that models the revenue in this scenario. And we are also asked to find the maximum revenue the hardware store can make. What price does the hardware store manager need to sell the batteries at in order to earn this revenue? While we do know that the manager wants to raise the price of the batteries, and he wants to specifically raise the price by 10 cents or make 10-cent increases, what we don't know is how many times the price is going to increase. So because we don't know this amount, we need to assign a variable to it. So we could say let x represent the number of price increases. So x is going to represent the number of times that the price of the batteries will increase by 10 cents. Part A of the question asks us to come up with an algebraic expression that can model the revenue for this scenario. So I'm going to use the letter capital R to represent revenue, and typically the capital R is used to represent revenue in these types of word problems. And in order to find out how much money the company or the store will earn, it's going to be dependent on the price of the item in question, which are the batteries, multiplied by the number of packages of batteries that they can sell. Now, there are some changes that are happening to both the price, and the number of packages will then therefore change as a result of changing the price. So let's start with coming up with an expression for the price. So the original price of a pack of batteries is $4.95. However, the store manager wants to adjust that price. He wants to increase the price of a pack of batteries by 10 cents. So an increase will be modeled by a plus sign. 10 cents can be written as 0.10, and that's the 10-cent increase. However, we don't know how many times they're going to increase the price. So we're going to put in our x variable here. We're going to close the bracket. And then let's come up with an expression for the number of packages. Now, typically, in a week, the store can sell about 600 packages of batteries. So let's put 600 into our bracket. However, if they go ahead and increase the price of the batteries, then their weekly sales will decrease by 10 packages. So a decrease could be represented by putting in a minus sign. They're going to lose 10 packages, but that amount is going to be dependent, or it'll grow depending on how many times they increase the price. So we still need to put in that factor of x. So to come up with a complete or final algebraic expression or equation, what we're going to have to do is take these two binomials and multiply them together. Basically, what we're going to do is expand them out. So in order to expand this expression, I'm going to use the FOIL method. So I'm going to start by multiplying 495 or 4.95 by 600, and that is 2,970. Then we have 4.95 multiplied by negative 10x, which is negative 49.5x. Then we have 0.10x multiplied by 600, which is a positive 60x. And finally, we have 0.10x multiplied by negative 10x, which is a negative x squared or a negative 1x squared. And remember, you don't have to necessarily put in that 1. The next thing I want to do is collect any like terms, if there are any, and also put my equation in proper order. And what I mean by proper order is just take your standard form equation and have your x squared term first, your x term in the middle, and your constant number or your plain number at the end. So if I look at my terms in my equation, I do have some like terms. I've got a negative 49.5x and a 60x. So together, they could be put together or added together, and we're going to collect like terms in our next line. So in order, my first term would be the negative x squared. And then I have negative 49.5 plus 60, which is a positive 10.5x. And then finally, I have my positive 2,970 at the end. So the equation that we've just created models the revenue for this particular scenario. Now in part B, we were asked to find the maximum revenue that the hardware store can make. The word maximum revenue implies that we want to find the vertex. We want to find the highest point on our parabola, which represents the maximum revenue or the maximum amount of money that the hardware store can make once they increase the price of their battery packs. Now, to find the vertex, when we have an equation that is currently written in standard form, means that to go from standard form to vertex form, we need to complete the square. If you're not familiar with the process of completing the square or you need a refresher, I'll post a link down in the description box below of a previous video that I put together that describes how to complete the square. The first thing that we want to do is put a bracket around just the first two terms in our equation. So that's the x squared term and our term with the x. The next thing we want to do is look at these two terms and just the numbers that are in front. So for the x squared, we've got a negative 1. And for our x term, we have a value of 10.5. We need to pull out a common factor between those two numbers. The only thing they are going to have in common, however, is just a negative 1. So I'm going to go ahead and pull out negative 1. And then inside the bracket, I'm going to write what would be left over if I divided these two terms by negative 1. So that's going to leave me with x squared minus 10.5x. And I'm going to keep the outside the same. I still have a positive 2,970. The next thing that we need to do is come up with what we call a perfect square trinomial. So that involves exclusively working with the b value in our standard form equation. So off on the side, I'm going to take my b value, which is a negative 10.5. We need to divide this number by 2, but we also need to square it. So negative 10.5 divided by 2 would be negative 5.25. Negative 5.25 squared would work out to be 27.5625. So it is a bit of a longer decimal value. So just to keep the numbers a little bit more condensed, what I'm going to do is round this answer to 2 decimal places. So I'm going to keep it at 27.56. So this value is now going to be added and subtracted inside the bracket that I have in my equation. So I now am left with r equals negative 1. Inside my bracket, I've got x squared minus 10.5x plus 27.56 minus 27.56. I closed off my bracket and I recopied my plus 2,970. The next thing we need to do is take the number that we subtracted, so that would be the negative or minus 27.56, and we need to pull it out of the bracket. But the rule says, or the rule is, that when you pull this term out of the bracket, you need to multiply it by the value or the common factor that is at the front of your equation. So for us, we've got a negative 27.56 multiplied by a negative 1. That's going to turn into a positive 27.56. So my positive 27.56 is now outside of my bracket, and I go ahead and recopy my positive 2,970. The next thing we want to do is collect any like terms on the outside of our bracket, and so we are going to add together the two numbers at the end of our equation. So I'm going to recopy the entire front portion. $27.56 plus 2,970 is a positive 2,997.56. Our last step is to come up with the factored expression for our perfect square trinomial. So we're going to keep our common factor in the front, which was our negative 1. We're going to create a smaller little bracket. We are going to square that bracket, and we're going to recopy the number on the outside of our equation. So 2997.56. Inside my bracket, I'm going to keep the letter x, since that was the variable we were working with. And to figure out the number that goes inside of my bracket, I'm just going to simply take my b value, so negative 10.5, and I'm going to divide it by 2. So I'm going to do that here off on the side. So negative 10.5 divided by 2, which works out to be negative 5.25. So negative 5.25 is going to go inside my bracket. So this is my final equation in vertex form. From this format, I'm going to be able to read off what my vertex should be, and from there we will be able to interpret that as a maximum revenue for the hardware store. Recall that when you are reading a vertex from a vertex form equation, the vertex comes from the h and k values. So the h value is the value inside of the bracket. The k value is the value outside of the bracket or at the end of your equation. A vertex is a coordinate point. So I'm going to open a bracket. And so my h value in my vertex form equation reads as negative 5.25, but when we are expressing that as a vertex point, we always record it as the opposite. So it's actually going to be a positive 5.25. And the k value can be written as is. I'm just going to make this a little bit bigger so I can fit my number in here. My k value is going to be 2,997.56. So the vertex for this particular parabola is located at 5.25 and 2,997.56. So in terms of what this vertex actually represents, your k value, okay, is a y value for your coordinate point. And in this particular situation, it is also going to represent your maximum revenue. So the maximum amount of money that the hardware store could expect to make if they do go ahead and increase the price of their battery packs is $2,997.56. The only way that they can earn this maximum revenue, however, is if they increase the price of their battery packs 5.25 times. So this H value, or the first half of your vertex, represents the number of price increases that have to occur in order to earn this maximum revenue. The second half of question B also asked you to determine what price does he need to sell the batteries for in order to earn this revenue. So we know the number of times the price has to increase, that's 5.25. So what we can do is go back to our very original equation and specifically focus on the piece of the equation that represented the price. So that's this first expression or first bracket here, the 4.95 plus 0.10x. So what I'm going to go ahead and do is recopy that down here, and in the place of x, I can substitute what I know about the number of increases, which that is that it has to increase 5.25 times. So if I go ahead and calculate this, I'm going to get an answer of 5.48. It actually works out to 5.475, but I rounded my answer to 2 decimal places since a price value is normally represented by 2 decimal places. So therefore, in order to have that maximum revenue of $2,997.56, the price of the batteries has to increase 5.25 times to end up with a final price of $5.48. A computer software company models the profit on its latest game using the relation P equals negative 2x squared plus 28x minus 90, where x is the number of games it produces in hundred thousands and P is the profit in millions of dollars. We're asked to determine what is the maximum profit the company can earn, how many games must it produce to earn this profit, and what are the break-even points for the company. And as a hint or a tip, for a company to break even, its profit must be 0. In question A, we're asked to find the maximum profit that the company can earn. That word maximum indicates that we need to find the vertex. Now, we were already given an equation to work with in the question, so all we need to do is take this equation, which is currently in standard form, and we need to convert it into vertex form. So that way we can read off the vertex and then interpret that as a profit. So I've gone ahead and recopied the equation, and I've placed my first 2 terms in my equation inside a bracket. I need to find a common factor between negative 2 and 28. So a common factor that I can pull out would be a negative 2. And then inside the bracket, I'm going to write what would be left over. So that would be x squared minus 14x. And on the outside of my bracket, I still have a minus 90. Next, I need to come up with my perfect square trinomial. So I'm going to focus just on my b value, which is negative 14. And on the side here, I'm going to do negative 14 divided by 2, also squared. So negative 14 divided by 2 is negative 7. Negative 7 squared is 49. So we're going to recopy our common factor. We're going to keep our bracket. We still have x squared minus 14x, but now we are going to add 49 and subtract 49 all within the same bracket, and we still have our minus 90 on the end. Our next step is to take the term that we subtracted, the minus 49, and we're going to pull it out of the bracket. When we pull it out from the bracket, we also have to remember to multiply it by the common factor in the front of the equation. So we've got a negative 49 multiplied by negative 2, which is going to give us 98. So the positive 98 will be on the outside of my bracket along with the minus 90 that was already there and that we've been carrying down on each line. We're now going to collect like terms, so I'm going to take my positive 98 and subtract 90, which is going to leave me with just 8. So the rest of the equation gets recopied. Our final step is to factor our perfect square trinomial inside the bracket. So I'm going to keep my common factor of negative 2. I have a smaller bracket which needs to be squared, and then I still have my value of plus 8 on the end. I'm going to put an x inside my bracket. And then to figure out the remaining value, or the factored value, I'm going to take my b value of negative 14, and I'm going to divide it by 2, which will give me negative 7. So inside my bracket, I'm going to place a negative 7. So the vertex for this particular parabola would be found at 7 and 8. Remember that your y value of your vertex represents your maximum. So the maximum profit that this company can earn, well, is it $8? That doesn't seem right. It seems a little low. But if we go back to the original question, it tells you in the question that their profit is measured in millions of dollars. So this is not just 8, it's actually 8 million. So our concluding statement would then be, therefore, the maximum profit is $8 million. Part B of the question asks us, how many games must it produce to earn this profit? So this answer is going to come from the first half of our vertex. And the first half, or the first part of the vertex, was a value of 7. This value represents the number of games that can be produced at the maximum profit. So we know our maximum profit is $8 million. But does that mean they only make 7 games in order to generate $8 million? Well, if we go back to our original question, they tell us that X is the number of games that the company can produce in hundred thousands. So that actually means that the company can make 700,000 games in order to earn a maximum profit of $8 million. So we can state that 700,000 games must be produced in order to earn the maximum profit. For part C, we're asked to determine the break-even points for the company. And you were provided with a hint that in order for a company to break even, its profit must be 0. So this is a point where the company is not making money, but they're also not losing any money. So if we know that the profit is going to be 0, or must be 0, then what we can do is go back to our original equation that was given to us in the question, and we can set the profit equal to 0, which means in the place of the letter P, we're going to put in a 0. Substituting a 0 in the place of profit means then that we are going to have to solve for x. And when we're solving a standard form quadratic equation for our variable, this implies that we need to factor the equation, or that we're at least going to try to attempt to factor the equation. So the first thing we should always check for, is there a common factor that we can pull from the equation? So there is a common factor of negative 2. So I'm going to divide all of the terms in my equation by negative 2, which is going to leave me with x squared minus 14x plus 45. I then want to check if this trinomial can be factored even further. So I'm going to try to factor it using the product and sum method. So what this means is that I'm looking for two numbers that are going to multiply to give me 45. 45 is my C value. But I also need those same two numbers to add up to negative 14. And negative 14 is my B value. So there is a number combination that will work, and that is going to be negative 9 and negative 5. So I'm going to take my two factors and write them in brackets. So I've got x minus 9, x minus 5. And in order to solve for my break-even points, I now need to solve for x, which requires me to take each of my factors and set them equal to 0. So I've got x minus 9 equals 0, and x minus 5 equals 0. So one of my factors, or one of my break-even points, is going to be a 9, and the other one is going to be a 5. Now remember that x represents the number of games that are made or produced in hundred thousands. So this is not just 5 games and 9 games, it's actually 500,000 games and 900,000 games. So to conclude, we could say, therefore, the break-even points are at 500,000 games produced, and again at 900,000 games produced. A common Maximin word problem involves figuring out mystery numbers. The sum of two numbers is 26. The sum of their squares is a minimum. Find the numbers. And as a hint, you are told that sum of their squares means to square each number and then add them together. Since I have no clue whatsoever what these numbers are or what they could be, I'm going to need to assign variables to represent them. It doesn't matter which letters you choose as your variables, I'm just going to simply use x and y. So I have let x represent the first number and let y represent the second number. The next thing we need to do is actually come up with an equation based on what they told us about these two numbers. Now in the question, they tell us that if we take the sum of the two numbers, we will get 26, meaning if we take these two mystery numbers and add them together, it will equal 26. So let's just use the letter S for sum. And I know that if I take my first number, which we're using the letter X to represent, and I add to it my second number, that's going to be represented by Y, I'm going to get a sum. They've also stated in the question that the sum of their squares is a minimum. Now, the squares in the hint was told to us that it just means to square each number and add them. So we've already added the two numbers together, so all we need to do now is square each of these numbers. And if we add together the squares, this sum is going to now be a minimum. And seeing that word minimum in the question just implies to us that we're going to eventually take our equation and complete the square to turn it into vertex form. Now, the only issue that we are left to deal with is we cannot solve an equation for two variables at a time. We can only solve for one variable or one letter at a time. So what we need to do is turn an x into a y, or if you prefer, you can turn y into x. And in order to do that, we need to go back to what they told us about the sum of the two numbers being equal to 26. So I know that x plus y is equal to 26. And so what we're going to have to do here is a little bit of rearranging and substitution. So it's going to be your choice. You can choose whether to isolate or rearrange this equation to solve for either x or y. I'm going to choose to rearrange and isolate for y. So that means I'm going to take this x term and bring it over to the right-hand side. That's going to leave me with y equals 26 minus x. So what I can do now is take this little mini equation and substitute it into my original equation in the place of y. So that's going to leave me with s equals x squared plus, I'm going to open a bracket, I'm going to put in 26 minus x, I'm going to close the bracket, and it is still squared. And now remember, anytime you see a term being squared, that means you need to write it out twice. So we now have a set of binomials that we need to expand out. So we are going to FOIL these two brackets together. So when I expand my two brackets, I am left with 676 minus 26x minus 26x plus x squared. My next step is to combine any like terms together. So I have x squared plus another x squared, which is going to give me 2x squared. I have negative 26x minus 26x, which is going to give me negative 52x. And then I have my positive 676. So this is an equation now in standard form. If we want to figure out the minimum, we need to complete the square in order to turn our equation into vertex form. So the first thing we need to do is put a bracket around the first two terms of our equation, and we're going to pull out a common factor. Our common factor is going to be a 2, and what would be left over would be x squared minus 26x. And we still have plus 676. We next have to create our perfect square trinomial, so we're going to take our b value of negative 26, we're going to divide it by 2 and square it off on the side. Negative 26 divided by 2 is negative 13. Negative 13 squared is 169. So we're going to go back to our equation. And inside our bracket, we are going to add 169 and subtract 169. Our next step is to take the term that we were subtracting, so this negative 169, and we're going to pull it out of the bracket. But remember that once we pull that term out, we also need to multiply it by the common factor that was at the front of the equation. So on the side here, I'm going to have a negative 169 multiplied by 2, which is negative 338. So negative 338 is going to now be found on the outside of the bracket. We're now going to collect like terms by putting together negative 338 plus 676. So we'll recopy the front end of our equation. Negative 338 plus 676 is actually positive 338. Our last step is to factor our perfect square trinomial inside the bracket. So that requires taking our b term of negative 26 and dividing it by 2. So negative 26 divided by 2 would be negative 13. So now that we have our equation in vertex form, we can identify our vertex. So according to our equation, our vertex is going to be located at 13 and 338. Now remember that the y value of your vertex is always going to represent your maximum or minimum. Now in this particular question, we were told that the sum represented a minimum. So our minimum value here is 338. The first half of the vertex is an x value, and so 13 represents x. Now, according to how we defined our variables at the beginning of this question, we said that x represents our first number, our first mystery or missing number. So one of the missing numbers actually is 13. So now that we know that the first number is 13, we just need to go ahead and find the second number. The second number was represented by the letter y. So you have a couple of choices. You can go back to your original equation, which was s equals x squared plus y squared, and you can use this to solve for y. Or the much simpler way to do it would be to use this expression or this equation that we came up with here. We know that y is equal to 26 minus x. So we can go ahead and plug in 13 in the place of x. And so 26 minus 13 is 13. Therefore, we know that our first number is 13. And our second number is also 13. When both numbers are 13, if you were to take the sum of their squares, you would get a minimum value of 338. The last example is going to be one that you can try on your own. It is very similar to example number 2. So if you need a refresher, you can go back and look at how we solved question or example number 2 before you try example number 4 on your own. A community center produces revenue of R equals negative 60t squared plus 600t, where R is the revenue and T is the ticket price in dollars. Profit is calculated by taking revenue subtracted by expenses, or P equals R minus E, where E is the expense equation. Francine, the manager, found that the expenses for the dances are not really constant. She found that expenses are equal to E equals 1,000 minus 90t. So this is what models the expenses for each dance. You are asked to find the break-even price for the tickets and find the maximum profit and the ticket price that yields this profit. Remember that when you are finding the break-even price, you are setting profit equal to 0 and you are using factoring to solve for your variable. If you are looking for your maximum profit, you need to take your standard form equation and complete the square in order to turn it into vertex form so that you can then identify the vertex and therefore the maximum profit. Pause the video and give this question a try on your own, and when you're ready, you can come back and take a look at the full solution. We are told that profit is equal to revenue minus expenses, and revenue and expenses each have their own equation. So the first thing you should start off by doing is plugging those equations into their proper spots. So revenue is represented by negative 60t squared plus 600t, and expenses is represented by 1,000 minus 90t. So before we can even do anything, we need to simplify this equation. So we do have a negative 1 here in front of our second bracket, our expense equation. And so we are going to have to distribute that into our bracket. So once we distribute, we've got negative 60t plus 600t minus 1,000 plus 90t. We now need to collect any like terms that are present in the equation, and I forgot a squared, so I'm just going to add that in here. So I do have like terms with 600t and 90t, so I can add those two together, and that's going to leave me with a final profit equation of negative 60t squared plus 690t minus 1,000. So first part A asks us to find the break-even price for these dance tickets. So I have an equation right now that is in standard form. To find the break-even prices or the break-even points means I need to find my x-intercepts or my roots or my zeros, and the only way I can do that is to attempt to factor my equation. So the first thing we should always check for is there a common factor that could be pulled out? Unfortunately, there is no common factor amongst 60, 690, and 1,000. So I can't pull out any common factor. I can then try to use decomposition in order to factor this, but I mean, the numbers are quite large. If you want to go ahead and try using decomposition, you can, but I can tell you that this equation is going to be unfactorable. So that means in order for us to find our zeros or roots, we are going to have to use the quadratic formula. Before we get ready to use that formula, what we want to do is just identify what are our A, B, and C values. So my A value is negative 60, my B value is positive 690, and my C value is negative 1,000. So I've put the quadratic formula equation on the screen, and now I'm ready to go ahead and substitute my values for A, B, and C into the formula. Once you plug all your values in, you're ready to start simplifying. Just be very careful with your integers. Pay attention to whether numbers are positive or negative. So when you simplify what is underneath the square root, you should get positive 236,100. and you are then ready to go ahead and solve for t. You should get two possible answers for the tickets, and one of them is 1.70, so that was rounded to 2 decimal places. The other possible solution is 9.80, and again, that number was rounded off to 2 decimal places. So we can conclude then that the break-even price for tickets will be somewhere between $1.70 and $9.80. So what does this really mean? It just means that a ticket price of $9.80 produces a greater revenue per person, but perhaps fewer people will attend at that ticket price. Whereas a price of $1.70 per ticket produces much less revenue per person, although many more people are likely to attend. These two amounts are the zeros or the roots of this particular profit equation. Okay, so any ticket price between $1.70 and $9.80 will result in some kind of profit. For question B, you were asked to find the maximum profit and the ticket price that would yield this profit. Now, what we've seen in this lesson so far is that anytime we're asked to find a maximum or a minimum, that signifies that we need to take our equation in standard form and go through the process of completing the square in order to turn it into vertex form. And then once we had that, we would read the vertex off of that equation. However, with this particular question, we have a little bit of the work already done for us because they asked us to find the roots in part A of the question. And as you might already know, you can go through finding the vertex just by using the roots. And to do that, we can start by actually finding the axis of symmetry. So to find the axis of symmetry, I need to take one of my roots and add it with my second root. So I have 1.70. And to that, I can add 9.80, and then I'm going to divide by 2. So if I do the math, that leaves me with a value of 5.75. Now, to find the second half of my vertex, I can take my axis of symmetry value of 5.75 and plug it back into my original equation. So I've gone ahead and recopied my original equation, and now anywhere I see the letter T, I'm going to plug in 5.75. So following the rules of BEDMAS, the first thing I should do is take 5.75 and square it. That gives me a value of 33.0625. I then can go ahead and perform the multiplication from left to right. And then I can go ahead and collect like terms to find my final value for the profit. So the profit works out to be $983.75. So this number represents the maximum profit. Now, in terms of what the 575 represents, 5.75 is the ticket price that would have to be charged to each of the patrons of the dance in order to earn that maximum profit of $983.75. We can write a final concluding statement saying, therefore, the maximum profit is $983.75 with a ticket price of $5.75.